Hi, this quick video is a hint on how to get started with the freefall across the universe activity. Now, it might be activity 9.4, or if this is a different year, it might have changed an activity number, but we're looking at freefall across the universe. Please reference the slides for all the info, but I'm going to remind you on how to use a spreadsheet real fast. So first thing, we're trying to solve for the distance versus time for something in freefall on Earth versus different planets. So we get to choose all these different planets. You'll need to pick 4 of them. I'm going to demo what to do for Earth real fast. So for this one, remember that if we're looking for distance of something that is accelerating, we're going to be using the equation d equals ut plus 1/2 at squared. But for this problem, or for this activity, we're assuming the initial velocity is 0. So we can get rid of that first ut term. So really what we get is d equals 1/2 times acceleration times time squared. So on a spreadsheet, in order to enter the data, first thing I need to do is type in equals, so that way our spreadsheet knows that we're doing a formula and we want it to do the calculation. Instead of typing 1/2, I'm going to type 0.5 because it works a little bit better with decimals. Then I say times, and I'm going to type in my value of 9.8. So notice we put the value for gravity up here for us. You just need to actually type in the value 9.8 unless you know how to do fixed cell references. And then last but not least, you're going to say times, and then we click on the actual cell for time. The reason why we do this is because all of our times are listed over here, so we can quickly use that to help us fill down later on. Now it's time squared, so I do shift 6 and a caret symbol for the exponent, and then 2 to square it. I'm going to do that one more time to make sure that my computer recognizes the pattern. So 0.5 times, and then I say 9.8, since that's the value for gravity on Earth, times, and then I click on the cell for time, and then I square it. All right. Now I can highlight my 2 cells, and then grab this little blue square and fill it down, and we've got our data for this one. Now when you graph this, you're going to highlight the time column as well as all of the other columns over here, and then you will go to Insert and Chart, and you'll want to be using a scatter plot. So in this case, we'll switch down to a scatter plot. Now you'll need to do all of the data for another 3 planets. Now, as you enter that data for other planets, you'll notice that your graph updates. So for example, if I quickly put in the data for Mercury, oh, little error. Oh, had an extra decimal point. Okay, so if we quickly fill in some of the data for Mercury, we can see that that began to fill in some of the data on my graph down here. So after you've got your at least 4 planets, if not all of them done, you'll need to graph it just like that. Afterwards, you'll need to switch over and do the same thing, but for calculating velocity of something in freefall. If you don't know what equation to use for that, think of something that is accelerating at a constant rate. How would you figure out its velocity given its acceleration? And then last but not least, you'll write your conclusion in the box for the conclusion on the last tab. That's it for this one. Hopefully that helps.